Voiceover. There is a stretch of sand along the Persian Gulf where the most expensive vertical real estate in human history stands in a neat, terrifying line. This isn't just luxury. This is Dubai. Here, three hyper-slender towers rise into the desert sky, 425 meters, 435 meters, and 472 meters tall. Built between 2012 and 2022, their combined sellout runs deep into the billions of dollars. And by design, every single one of them is leaning, swaying, and flexing in the high-altitude Gulf winds. That is not a structural defect. That is advanced engineering. At a slenderness ratio of 15:1 or worse, a rigid skyscraper doesn't survive. It snaps. The structural engineers knew the physics. They simulated the wind profiles, tested the aeroelastic models in wind tunnels for months, and built around it. In two of these three ultra-luxury towers, the engineering defense was identical. A massive, multi-hundred-ton suspended counterweight installed near the crown, calibrated to swing opposite the building's movement and neutralize the kinetic energy before it reaches the penthouses. A tuned mass damper, but one megatower. The crown jewel that generated $3.1 billion in initial sales and defined the Marina skyline went up without one. No pendulum, no damper. The Dubai Marina Pencil Tower file is open. This is not a story about three skyscrapers failing the same way. It is the opposite. It's a story of three identical structural challenges, where two developers paid for the ultimate mechanical fix, and one did not. Today, that single choice has left the region's most expensive tower locked in multi-million-dollar lawsuits, its resale market in freefall, and owners alleging systematic fraud. Why did a multi-billion-dollar supertall go up without the most critical piece of comfort engineering available? To understand the chaos on the upper floors, we have to look at what happens when desert winds hit a hyper-thin glass needle. Drop your thoughts in the comments. Is a missing damper a legal defect, or just the risk you take when buying the sky? Voiceover. To understand the engineering crisis shaking Dubai's luxury market, you have to look at the timeline of how these pencil towers altered the skyline. The boom began in the early 2010s, radiating out from downtown Dubai and the marina. Wealthy buyers demanded uncompromised, 360-degree views of the Palm Jumeirah and the Arabian Gulf. To give them that, architects pushed structural proportions to the absolute limit. The fundamental engineering challenge wasn't just height. It was the slenderness ratio. A typical skyscraper has a stable base, but these towers were built on restricted, hyper-expensive plots, resulting in footprints that look like thin concrete needles. When high-velocity desert winds slam into a structure of these proportions, the air doesn't just roll past, it detaches, creating alternating columns of low pressure on opposite sides of the facade. This is von Karman vortex shedding. In simple terms, the wind aggressively grabs one side of the skyscraper, releases it, grabs the other side, and repeats. If this cycling locks into the building's natural sway frequency, the tower begins to violently oscillate in resonance. For two of the towers on the marina waterfront, developers anticipated this. The thinnest of the trio, rising over 440 meters on a knife-edge base, was engineered with a massive 800-ton tuned mass damper at its summit to absorb this motion. But the developers of our centerpiece tower chose a different, single defense strategy. Instead of a mechanical pendulum, their engineering timeline relied entirely on aerodynamics, leaving open mechanical floors. Large, louvered structural voids every 12 stories. The theory was that wind would pass cleanly through the building, disrupting the vortex shedding before resonance could build. In 2015, construction wrapped. The municipal inspectors signed off, the engineering consultants stamped the blueprints, and the developer handed over the keys. On paper, it was a compliance triumph. The building met every structural safety code enforced at the time. But as the desert heat rolled in and the high-altitude winds began to howl, the gap between structural survival and actual human livability began to tear the project apart. Did the engineers rely too much on computer models? Or did the developer cut the ultimate corner? Let me know what you think below. Voiceover. The parallel between these three supertalls highlights a critical reality of the UAE luxury market. The difference between a successful asset and an unlivable nightmare is completely hidden inside the mechanical complex. Look at the tower next door in the marina. It is visually thinner, completely exposed to the Gulf gales, and designed to flex up to a meter in extreme weather. Yet, its residents aren't organizing mass legal action. Why? Because their motion is actively damped by that 800-ton counterweight at the top. The energy is absorbed before it shakes the structure. Our centerpiece tower, however, relies solely on those open, louvered mechanical floors. And this is where the unique environment of Dubai turned a calculated engineering choice into an operational disaster. In the UAE, you aren't just dealing with wind. You are dealing with hyper-dense coastal fog, extreme salt air, and blistering summer heat exceeding 45 degrees Celsius. By leaving those double-height mechanical floors entirely open to disrupt the wind, the design exposed the building's core internal infrastructure, its high-pressure water pumps, electrical risers, and cooling lines directly to the harsh Arabian climate. The consequences of this parallel exposure were immediate. When the extreme summer heat hits the exposed concrete slabs of the mechanical floors, thermal expansion causes the structure to creak and groan as different sections expand at varying rates. When the winter humidity and sea salt roll through those open voids, they attack the ceiling joints and pressure valves. The structural engineers met the code for safety. The building will not fall down. But by choosing the open-air aerodynamic fix over the heavy mechanical damper, they created an unforgiving environment for the building's utilities. Two towers on the same strip faced the exact same physics. One spent the capital to contain the kinetic energy inside a sealed penthouse. The other let the elements march straight through the center of the tower. If you bought a luxury flat, would you trust an open-air wind void? Or would you demand a physical counterweight? Drop a comment below. VoiceOver. The real tragedy of this engineering gamble isn't found in the blueprints. It's found in the lived reality of the expats and high-net-worth investors who poured millions into the sky. Within 18 months of handover, the dream of ultra-luxury living evaporated into a chaotic sequence of mechanical failures. It started with the sound. In the high-altitude isolation of the upper penthouses, residents didn't just feel the wind, they heard it. During intense winter shamals, the powerful desert windstorms that sweep across the Gulf, the tower began to express its stress. Owners reported deep, structural groaning and metallic screeching that echoed through the concrete walls. Worse, the extreme sway caused internal utility lines to flex beyond their tolerance limits. High-pressure water pipes inside the walls vibrated so violently during wind events that luxury bathtubs became completely unusable. Door frames shifted out of alignment, preventing heavy glass doors from closing. Air pressure differentials created high-pitched whistling through elevator shafts and main doorways. Then came the climate-driven failures. Because the mechanical floors were entirely open to the elements, the intense ambient humidity and salt air rapidly accelerated material fatigue. Between 2017 and 2019, the tower suffered a series of catastrophic water events. High-pressure plumbing lines burst on the upper residential zones, sending thousands of gallons of water cascading down the interior core. Entire elevator shafts flooded, knocking out high-speed cabs for weeks and leaving residents stranded hundreds of meters in the air. In one terrifying incident during a storm, an owner was trapped inside an elevator cab for nearly an hour and a half as the automated safety systems struggled to handle the building's lateral drift. By 2021, the Homeowners Association had seen enough. They launched a massive multi-million-dollar lawsuit against the master developer. The legal filings paint a devastating picture, documenting hundreds of individual design and construction defects, characterizing the situation as an unprecedented failure of premium luxury development in Dubai. The developers fought back, claiming the building was an architectural masterpiece and that the issues were merely standard maintenance items requiring fine-tuning. But the legal pressure only intensified. A subsequent lawsuit, filed in April 2025, alleged outright fraud, claiming the developer possessed independent survey reports documenting widespread facade and structural degradation before units were even finalized. and intentionally withheld them from international buyers. If you had invested $20 million into a premium marina penthouse, only to find your elevators flooded and your walls groaning every time the wind picked up, what would you do? Would you sue? Or quietly try to dump the asset? Voiceover. The future risk for Dubai's Pencil Tower market is no longer a theoretical debate. The financial damage is visible right now in the land registry data. The global elite have looked at the litigation and walked away. Penthouse units that once commanded record-breaking premiums are sitting on the market, seeing devastating price cuts of 30 to 50% just to attract interest. While the rest of the Dubai luxury real estate market experiences historic growth, this specific tower is moving in reverse. The developer has spent millions on remediation, patching pipe networks, replacing flooded elevator electronics, and resealing the facade joints. But there is one fundamental flaw that no amount of money can fix. You cannot retrofit an 800-ton tuned mass damper into a fully completed, occupied super tall tower. The space isn't there. The structural columns weren't reinforced for that concentrated load, and the engineering pathway is completely blocked. The missing pendulum is a permanent condition. The real lesson here reaches far beyond a single address in the marina. It exposes a massive regulatory gap in global boomtowns. The local building codes enforce structural safety. They guarantee a tower won't collapse, but they do not regulate human comfort, wind acceleration tolerances, or how an engineering choice will interact with extreme desert heat and coastal salt over a decade. The engineers satisfied the code. The city approved the permits. The developer collected their profit, and yet the buyers are left with an asset that is operationally fragile. So, here is the final question this entire file turns on. If a luxury penthouse in this tower came up for sale today at a massive 40% discount, knowing it is structurally safe but lacks the comfort engineering of its neighbors, would you buy it? At what price point does the discount outweigh the reputation? Tell me your number in the comments. I read them all. The Dubai Pencil Tower file is closed.